angular momentum is denoted by L, remember, of a body. Let us take it like that. Suppose this is my y-axis as usual, and this is x-axis, and the vertical is z-axis. Okay, and then let us take that we have position vector is r, and p, or we can call it as moment, linear momentum, which is mv, is acting in this direction. Okay, so how do we define angular momentum? The angular momentum L is defined as R cross P. The angular momentum L is actually a vector quantity. Okay, it has a direction, and what would be the direction? The direction will be along z axis. You can easily see how the two vectors are rotating. Okay, you can in fact also find an analogy. If P can be referenced with O, something like that. This is P, and then R cross P would actually be something like that, isn't it? So it will give you the direction towards Z axis. Okay, so we can also write in terms of thing modulus R and P sin theta. Okay, or we can simply say RP sin theta. ये क्या है? This is my absolute value, okay, of the vector. So if theta is 0 or 180, the value of L would be 0. Okay, so case 1, if theta is 0 or theta is 180 degree, L would be 0. And if theta is 90 degree, then angular momentum would be sin 90 would be 1. So RP sin 90, which is simply R times P. Is this clearly understood? We can also represent it in the vector form. We can take capital small r as xi cap, y j cap, z k cap, and then p can be written as px I cap, py j cap, pz k cap. Okay, so r cross p can be written as I j k x yz, px, py, pz in this form, okay, which can actually be represented as Lx I cap, Ly j cap, Lz k cap, okay. And as such you already know क्रॉस जब वेक्टर दो वेक्टर का क्रॉस प्रोडक्ट होता है तो उसको कैसे सोल्व करते हैं, that I have already taught you in vector chapter. So you can from here you can actually take a cue accordingly. Now we can also know one fact that we already knew what is torque. Torque tau, which is again a vector quantity, is given as r cross f. Okay, we had already discussed this. So an angular momentum L is actually r cross p. Okay, now suppose I make dl by dt, dl by dt. So obviously I will have to do d by dt r cross p, okay. And if you use the product rule, so what will you get? Dr upon dt, okay, and then cross p, and then plus r as it is, and you will say dp by dt. Okay, this is the product rule of differentiation, which I had already taught you earlier. So dr by dt is actually v, so we can write v cross p, okay, and plus r, and here remember this is cross again, r cross dp by dt क्या होता है? If you remember, it is f. Do you remember? It's a force. So if you see, v cross p will be v cross mv, which is mv cross v. सेम वेक्टर को क्रॉस करेंगे तो जीरो हो जाएगा, okay. So we can say this is 0 plus r cross f. And what is r cross f? Do you know? r cross f को क्या कहते हैं? दक्ष. Very good. Torque होगा. शाबाश. So it would be torque, okay. So what is our understanding now? That the rate of angular momentum is nothing but the torque itself. Again, this formula can be asked for proof in your examinations, or maybe you are encountering a problem which is based on this. So is this clearly understood? Let us do one question. Find the torque of a force and force is given by F equal to 7I cap minus 3J minus 5K, okay, about the origin which acts on a particle, whose position vector vector r is given as I plus j minus k. So can you calculate and tell me the answer? Write down your position vector f. F is 7i minus 3j minus 5k, and r is given as I plus j minus k. And what is your formula? Tau. You have been asked as tau, it will be r cross f. So you can write down I j k 1 1 minus 1, 7 minus 3 minus 5. So can you tell me what is the value? Okay. So your answer would be I cap negative 5 negative 3, then minus j negative 5 negative negative plus 7. So okay, and then plus k negative 3 negative 7. So your answer is negative 8 I cap, and then plus 2j, 7 minus 5 minus 2j, okay, and then negative 10k cap. Okay, so this is your tau or the torque, and torque is measured in Newton meter. So as a vector quantity, it will be this. Now if you are asked what is the absolute value of torque, how will you calculate? Batao. What? How many Newton meter of torque is generated? So you know, until you really work hard, you won't know. So you are asked to tell me the absolute value, and I already told you in the vector chapter, absolute value would be negative 8 whole square plus negative 2 whole square plus negative 10 whole square, and then under root. This is what? कोई भी वेक्टर a xi plus yj plus zk, उसका जो एब्सोल्यूट वैल्यू होती है क्या होती है? x square plus y square plus z square. See, until you revise your previous things, you won't recollect anything. So it is, revision is a must, and you must be very much close to your subject. So this is how you can know it is 64 plus 4 plus 100. So it is 168 square root 168 Newton meter. So this much of torque is generated. Okay. Is this understood or not? Let me give you yet another very good question, which is very frequently asked in the examination. Question: a 3-meter long ladder a 3-meter long ladder weighing 20 kilogram leans on a frictionless wall. on a frictionless wall. Its feet rest on the floor rest on the floor 1 meter from the wall. As shown in figure. Find the reaction forces of the wall and the floor. Please try. Yes, I am drawing figure. So simply a vertical wall, and this is your ladder. Okay, you can say the ladder is A, B. All right, and this is your 1 meter. All right, and ladders is how much? Already given as 3 meter. So you can take it as 3 meter. Now clear? Yes or no? So what are the various forces? First thing is that you have to know what are the various forces that are acting. Okay. How will you analyze? Obviously, you won't be able to analyze anything unless you visualize the issue. One way is that the upward reactionary force from the wall would be capital N. Right? True? And the friction would be in this direction, F, because it is clearly told in the question. And there is no friction on the wall. This is your wall. Wall is frictionless. Okay. And then obviously, since it is frictionless, this would be your force. Let us say this is some F1. Okay. The vertical force, and the midpoint would be the point where the center of mass would work. So this will be your W, weight of the ladder. Okay. So if we say AB and this is the point C, so what would be BC? Can you tell me? So it is 3 square minus 1 square, which is 2 root 2 meter. So BC is known, yes or no? Now let us understand what are the various forces that are acting. What are the various forces? Let us analyze. All vertical and horizontal force, let us analyze. Okay. The horizontal or the vertical force, so long it is in equilibrium, the vertical force should be equal. So vertical forces क्या क्या हैं यहाँ पे? one is N and the other one is W. It should be like this. N should be W. Also, we can see the frictional force, horizontal forces. Horizontal forces. What will happen? F should be capital F1. This is my second. Yes or no? ये हमने बताया था इक्विलिब्रियम के लिए आप लोगों को. Okay. So now let us take the rotational equilibrium. I have told that rotational equilibrium means the torque, anti-clockwise torque should be equal to clockwise torque. So what is my torque? Let us take कि हम जो टॉर्क का बात कर रहे हैं वो A पॉइंट ले लेते हैं. दैट पॉइंट A के अराउंड हम टॉर्क को. So what will be the torque? The clockwise torque will be, one will be W. So we can say F1 multiplied by BC, right? F1 multiplied by BC, that will be your anti-clockwise torque. Okay, F1 multiplied by BC, and that would be equal to what? W multiplied by AE. Supposing that this point I, this is A, so obviously इसको हम E कह देते हैं. Okay, because this would be your actionable torque. Okay, so let us just simply write down the values now. F1 multiplied by 2 root 2 equal to W. What is W? 20 मल्टीप्लाई, एंड 20 को हम और क्या कर सकते हैं? 20 ग्राम है ना, केजी है ना, जस्ट अ मिनट, 20 केजी राइट? हाँ करेक्ट. सो 20 केजी. Now here 20 kg means we have to also multiply it by 9.8 mg and multiplied by AE. What was my value of AE? So AE will be 1 by 2 meter, right? Alright. So what is the value of F1? F1 is 20 times 9.8 upon 2 times 2 times under root 2. Okay. So we can say that 2 2 ja, this is 4, 4 5 ja, okay. And then 49, correct, upon root 2. So that's my force. What do you say? Okay, so this will come out to be, we can say 1.41 से इसको divide कर दो. So we will get somewhere around 34.6 Newton. Okay. So F, small f is equal to F1, which is 34.6 Newton. Is that clear? Yes or no? So now, since there are two forces here, now go back to this. So what shall be my resultant force? The resultant force would be somewhere इन दोनों का जो somewhere here, yes, इसको हम F2 कह सकते हैं. So resultant force of these two would be capital F2, which is F square plus how would I say, N square, right? So we can simply write down plus N square under root. So what's the value? So value is 34.6 whole square, and N was how much? 196, right? Square. Okay, and then this. Clear? कोई गलती है? N कितना था? 20 kg था ना, तो न्यूटन में कन्वर्ट करोगे तो 9.8 से मल्टीप्लाई करोगे ना, तो कितना आएगा? ठीक है, ओके. सो F2 की वैल्यू आ गई हम हमारी. ऑल्सो इफ यू वांट टू नो व्हाट इज द एंगल ऑफ विद रेस्पेक्ट टू हॉरिजॉन्टल, इसको अल्फा ले सकते हैं, यस. सो tan alpha will be n by small f. So angle for tan alpha, we'll get tan alpha as capital N upon f, which is 4 under root 2, which is 5.65. Okay, and then alpha can be tan inverse. So you can simply write alpha is tan inverse 5.65. Okay, so that's how you can calculate all the related parameters. So if you go through the question once again, you will see that we have found everything, yes or no? We were asked find the reaction forces of the ball and the floor. So we will obviously have a vector quantity. So we have to tell in two terms. One, how much force and at what angle. Got it or no? So this is how we can think of solving torque related problems. Is this concept cleared or not? So we'll close this topic.